In this video, we're going to look at the preliminary example part B in section 13.1 and 13.2. So in this example, we're going to look at vector addition. So vector addition is pretty straightforward algebraically, and it also has some really interesting consequences graphically. So let's take a look. So here we have two vectors. We're told to let A be the vector 2i plus 3j, and B to be the vector 4i plus j. We're told to sketch the vectors A, B, and the sum of A plus B. And you may assume that the successive dotted lines are separated by 1 unit. So we have 1 unit represented in this graph. All right, let's go ahead and get started by graphing these two vectors. So feel free to pause the video and graph them on your own and then check your work. So we can graph 2i plus 3j moving over to the right 2 and up 3. So our vector would look like this. So here would be vector A. All right, now for vector B, we are going to move 4 to the right and up 1. So we can start at the origin also, 1, 2, 3, 4, up 1. So vector B looks like this. And I just decided to start both my vectors at the origin. You don't have to do that. It doesn't matter where a vector is located. What only matters is the directions and magnitude. All right, so now let's consider the vector A plus B. So in vector addition, how we add those two vectors is to just add corresponding components. So here's my A, and my B is 4i plus j. Okay, so what we can do then is add our i's together. So 2i plus 4i would just be 6i. And then 3j plus 1j would just be 4j. So then the sum of A plus B is 6i plus 4j. So let's go ahead and graph that as well. So we'll graph that in green. So we count over 1, 2, 3, 4, 5, 6 in the horizontal direction, and 1, 2, 3, 4 in the vertical direction. So then our vector would look like this. So that would be A plus B. So why does it make sense graphically for this vector to be the sum of A and B? Well, one thing that we can see here is if instead of drawing B down here at the origin, I drew it up here at the start of A, I would have gone over 1, 2, 3, 4, and up 1. I would have ended at that sum A plus B. And it turns out I could also have started with B and drawn A in 1, 2, up 1, 2, 3. So the sum of two vectors is the diagonal formed in the parallelogram when we take one of those vectors and then start the next vector at the end of the first. And it doesn't matter, notice, which order we add vectors in. So that's a really awesome way visually to see the sum of two vectors also. All right, thanks for watching. In the final video for these sections, we're going to look at some information about vectors and a summary box at the bottom of this page. Thanks for watching.